So now let's look at something called the constant multiple rule. And it says if f is differentiable, and c is a real number, then when I'm taking the derivative of c times f of x, it's equal to c times the derivative of f. So basically, when you have scalar coefficients here, and you're taking derivatives, you don't do anything with those coefficients, they just stay the same. Okay. So let's look at some examples here. So let's start with the function y equals 5x cubed. And I want the derivative of that function. So I want dy dx. I'm taking, according to the constant multiple rule, this 5 out here in front just stays the same, 5, and then I need to take the derivative of x cubed, and we're going to use the power rule there. So you'll get 5 times 3x squared, or 15x squared. So there's my derivative. Let's look at another one. Y equals 2 over x. So we're going to start by rewriting our function y. It's 2 times x to the negative first. And when I'm taking the derivative, we leave that 2 alone. 2 times the derivative of x to the negative first. I'm going to use our power rule here. Bring your negative 1 down in front, your power down in front, and then you're going to subtract 1. So I'm getting negative 2x to the negative second, which you can leave like that, or you can move it to the denominator as an x squared. And that would be my derivative. Let's look at this next one here. So number 3. Y equals 2 times the square root of x. So again, I'm going to rewrite my function. 2 times x to the 1/2. And now when I take my derivative, again I leave this front 2 alone, leave that part alone, and take the derivative of x to the 1/2 and do the power rule. Okay, so there's my power. You're going to bring it down, 2 times 1/2, and then subtract 1. This 2 and this 1/2 cancel. So you're just left with x to the negative 1/2, 1 over x to the 1/2, which is the same thing as 1 over the square root of x. All right, let's look at one more. Number 4. Y equals 1 over 2 the cube root of x squared. So again, we're going to rewrite our function. 1 over 2. This would be x to the 2/3. Well, my x is in the denominator. I'd really like for it to be in the numerator. So I'm going to write it as 1/2 x to the negative 2/3. And now we're going to take the derivative. And again, this 1/2, this coefficient just stays the same. I leave it alone, and I want to take the derivative of x to the negative 2/3. So we're going to do the power rule to get our derivative. 1/2 times a negative 2/3 x negative 2/3 minus 1. So if you multiply, you'd get a negative 1/3 x to the negative 5/3. And you can leave it like that, or you can move it to the denominator where it has a positive power, x to the 5/3 there. And there's my derivative, so that's dy dx. So if you have a coefficient, you don't do anything to that coefficient. They just kind of go along for the ride, and you leave them alone. One thing I do want to mention, make sure you're very careful with how you treat things. So let me give you a word of caution. I'll give you a particular problem. 5 over 2x cubed. You should go ahead and simplify the denominator first. You need to have it so you have x to a power by itself. So this would be 5 over 2 cubed x cubed. It's the same thing as 5 over 8x cubed. So now you can, and then move it to the numerator, 5 over 8x to the negative 3rd. Now you're ready to take the derivative. dy dx would be 5 over 8. Do your power rule here. Bring the power down. Negative 3, subtract 1, so it'd be minus 4. Minus 15 over 8, x to the negative 4th. That's my derivative. It's very important that you distribute, or that you simplify this exponent. Don't, with that 2 on the inside, you can't start by doing the power rule here. You need to multiply that out first, and then once you're done, you can do the power rule there.